So we are discussing today the parallel connection of capillaries, that is when they are kept horizontally. So we'll try to understand that how they behave, how the flow of liquid or the flow of fluid behaves through a capillary. So suppose these two capillaries are kept parallelly. So you just try to recollect when the resistors were connected parallelly like this. So you remember the current flowing through this is I. So through the first resistance the current was I1, and through the second resistance the current was I2. And what was constant? The constant was the potential difference. So V is constant. So you remember that whenever the connection of these capillaries were in series like this, the connection of these capillaries were in series. So at that time I told you, whenever the capillaries are connected in series like this, you can consider two capillaries like this, they are connected in series. Of course, you can find over here I am drawing the capillaries of different length and different cross-sectional area. Suppose this is R2 and this is R1. So always remember, whenever the capillaries are connected in series, at that time the volume flow per unit time is constant. Volume flow per unit time is constant. And what is this that I told you? The pressure difference across this capillary. Suppose I consider the pressure difference across the first capillary to be P1 and the pressure difference across the second capillary to be P2. So we'll consider the total pressure difference will be equal to the sum of the pressure difference P1 plus P2. Now let me consider this particular concept. Now in both the cases, one thing you can understand that fluid is actually flowing through this also, and fluid is flowing like this over here. So this is the flow of fluid you can consider. So this is the flow of fluid you can consider over here. Fluid is flowing something like this through these capillaries. So it is also flowing. So this is a series connection. Now I am discussing the parallel connection. So this is the parallel connection. So in case of parallel connection, always remember that the rate of flow, if I consider Q1, because we consider Q to be V by T, so this is Q2. So total rate of flow Q will be equals to Q1 plus Q2. Now what shall be constant in this case? Like in this case, potential was the causative agent, or for potential is difference is the main cause of flow of current. Similarly, in case of fluids, you know that pressure difference is the main cause of flow of liquids or fluids. So here P is constant. So you can see in case of series connection, your rate of flow of liquid, rate of flow of fluid, you can say, or liquid is constant. And in case of parallel connection, the pressure difference across the ends of the capillary is constant. So this is very, very important. So now how to proceed? I will just ask you to just recollect the famous Poiseuille's equation that I have already discussed. So in case of, you remember the Poiseuille's equation, that is, just if I write down once again the Poiseuille's equation. So this will be something like this, that volume per unit time through any capillary, that is also denoted by Q, I have told you just now, equals to pi by eta r to the pi by 8 r to the power 4, and then the pressure difference in the numerator, eta in the denominator, and the length in the denominator. So I think you remember that rate of flow of volume, rate of flow of liquid is directly proportional to the r to the power 4, and it is directly proportional to the pressure difference, inversely proportional to the coefficient of viscosity of the liquid, and inversely proportional to the length. So if I apply this for these two capillaries, say capillary 1 and capillary 2, so if I just apply this, so what can I write now? Q1 equals to, therefore I can write pi upon 8. Pressure difference is same, that be P, and that is equals to R1 to the power 4 divided by eta into L1. Similarly for capillary 2, this is for your first one, and for the second one I can write Q2 is equals to pi upon 8 P R2 to the power 4 divided by eta L2. So we can obviously write the total rate of flow, that is equals to Q1 plus Q2. So that will be equals to therefore pi by 8 P R1 to the power 4 by eta L1 plus pi by 8 P R2 to the power 4 by eta L2. So you can write down over here that is pi upon 8, and you can obviously take P by eta constant. So you can take R1 to the power 4 by L1 plus R2 to the power 4 by L2. So this is a very, very important expression for the total flow of the liquid through the fluid through this particular parallel connection of capillaries. And we have already discussed earlier that regarding the series connection, whenever the series connection takes place, I told you that in case of series connection, what was constant? You remember the rate of flow was constant. So in case of series connection, we can obviously say that Q is constant. The liquid is flowing through this, Q is constant. And this is L1, this is L2, and this is your suppose R1, and this is R2. So we can say the total pressure was equals to P1 plus P2. And we can obviously use this total formula of Poiseuille's equation once again, that Q is equals to pi P R to the power 4 by eta L. So we can obviously write P is equals to Q, that means pi by 8 Q eta L divided by R to the power 4, and over here I can write P. And obviously I can write a pi over here. So this can be written. So in this case, what you have to equate the pressure difference. So you can see I can directly put it over here. So P is equals to P1. So I can write for the pipe 1 8 Q divided by pi P eta, all are taken common. So L1 by R1 to the power 4 plus L2 R2 to the power 4. So this is a very, very important relation in case of your regarding this pressure. So pressure is already being taken over here. So I'll just write it over here like this. This is the total formula. So here you are getting P is equals to 8 eta, and over here you can find out that this is on the numerator, it is pi P R to the power 4. So I just equated this pressure over here and got this value. So this is a very, very important relation. You can just see, and you can just explore this more in your numericals. So I think it is very much clear to everybody. So you can just do this. Okay. So over here you can just put a you have done everything. Okay, fine. So this is the total calculation. So just start practicing this type of problems.